All right, we're going to start the idea of graphing equations. And what we mean by graphing an equation is if we look at a linear equation to start with. And so this is a linear equation. And it's linear because the power to the variables is 1. The power is 1 for x and y. Now, a, b, and c are real numbers, and x and y are variables. Both a and b can't be 0. One can be 0, but not both. So what we can do is we can find all the ordered pairs that solve these. So let's look at an example. X minus y equals 1. And what we'll do is I'll put a graph over here. And we'll give some. So that's our origin 0, 0. There's 1, 2, 3, 4, 5, 6, 7. And going up 1, 2, 3, 4, 5, 6, 7. And going down 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so we want pairs of numbers for x and y. So yeah, I'll go, you know what? Let's make x 0. What happens if x is 0? So I come over here. If x is 0, then minus y equals 1. So divide both sides by a negative, and y equals negative 1. So one ordered pair is 0, negative 1. I pick 0 because it's easy to solve for, so I'll do the same thing. What happens if y is 0? So I come over here and I have x minus 0 equals 1. So x equals 1. So the next ordered pair is 1 and 0. That gives me 2 points. Let's find another one. And you know what? I have 1 for x. Let's say I have, let's look for the ordered pair of 2. We'll increase one value on x. We'll see what happens if x equals 2. 2 minus y equals 1. Well, if I solve for y, I'm going to have y equals 1. And now I have a collection of points that describe all the possible answers. So let's plot 0, negative 1. So I go 0 in the x and down 1 in the y. So there's my first point. Then I want to look at my second point. I go over 1 and 0 in y. I look at my third point. I go over 2 and up 1. And if we connect the dots, we find that there's a line that connects these dots. And any point on this line, so for example, if I look at this point here, well, that's over 1, 2, 3, and up 1, 2. So 3, 2 is an ordered pair. And I come back over here, 3 minus 2 equals 1, and that works. And so this line is called the equation of a line. And the line has all the solutions that would satisfy that equation. And this is why it's called linear. It makes a line. Let's look at another one as an example. Let me draw my graph first. I will say graph paper is easier than a computer screen here, but we'll do what we can. And let me give myself some grid points. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. many years as I've been doing this, I should have a grid paper template. But I find when I'm doing things on the computer, it's sometimes easier to slow down if I have to draw everything. I know you've been watching computer lectures and you'll find they go a little fast, as if they were in person, but you at least get to be able to rewind and repeat things. So this is a linear equation because all the powers of the variable are in 1. And so I want ordered pairs that will work for me so that I can plot this. Well, the first thing I always do is I say, well, what happens is x equals 0. So if x equals 0, I get 0 minus y equals 4, negative y equals 4, y equals negative 4. So that's my first point. I go 0 in x and down 4 in y, which is right here. And let's do the opposite. Let's say what happens if y equals 0. So 2x equals 4, and x would then equal 2. So I go over 2, 1, 2, and x, and 0 and y. So there's another point. And then, well, what's a good point to check? I'll say what happens if x equals 1. And so if x equals 1, then I have 2 minus y equals 4, or negative y equals 2, or y equals negative 2. So 1, 1, 2, and there's my third point. And I now play connect the dots. And I have my line, the equation of a line. And so by graphing points, we can define equations of lines. There are some special lines that we need to be aware of. And the first are horizontal lines. Let me change colors here for a horizontal line. And so a horizontal line, if we look at a horizontal line, we could say that this is y equals some number a. Because whatever value of x I have, the y value is always the same. And so notice in this equation for a horizontal line, there's no x variable. We have it to the first power, but it's always a constant. And so y is always equal to a constant makes a horizontal line. Horizontal line. And then a vertical line. Well, that's the opposite. And you'll find opposites happen a lot when dealing with swapping x and y around. In this case, x equals some constant. And so no matter what value of y you get, x is always the same value. And this is a vertical line. And there'll be special lines as we dig into the properties of what makes these linear equations work. We will have to be aware of a horizontal line and a vertical line. All right, we'll continue exploring these ideas.